Good morning. Let us discuss about the 22nd January 2025 morning shift physics paper. And let me go for the first question here. The questions you can see in the PDF will be given in the link. Let us go for the first question here. It is given that a parallel plate capacitor of capacitance 40 microfarad is connected to a 100 volts power supply. So it is a parallel plate capacitor, and capacitance of the capacitor is given as 40 microfarad, and this capacitor is connected to a 100 volts power supply. So a battery of potential difference 100 volts, it is connected to this. Next, now the space between the plates is completely filled with a dielectric material of dielectric constant K is equal to 2. So after connecting to battery, after some time, the dielectric material of dielectric constant K is equal to is completely filled in the space. And due to the introduction of dielectric, we have to calculate the extra charge passing through the battery and changing electric potential energy stored in the capacitor. So two things we have to calculate here. One is after placing the dielectric, extra charge passing through the battery, and before placing dielectric and after placing dielectric, the change in electric potential energy. So these two things we have to find out here. Here you see in this condition, in both the cases, before placing dielectric and after placing dielectric, the capacitor continuously connected to battery. Battery will maintain always potential difference between two plates of capacitor as V0, as 100 volts only. So initially, when there is no dielectric, if I imagine charges on capacitor are plus Q1 and minus Q1, and we know that charge on capacitor will be CV0, C capacitance multiplied by potential difference. So initially the charge is CV0, and in the second case, between the two plates of the capacitor, when we completely fill the space with a dielectric material of constant K and keeping in connection with the same battery of potential difference V0, in the second case, to maintain the potential difference same, the battery will supply extra charge. Imagine in the second case, the total charge on the capacitor is Q2. Now, in the second case, you can write Q2 as the new capacitance, because dielectric is completely filled. New capacitance is K epsilon naught A by D, whereas initial is epsilon naught A by D. So K times to initial, and same battery, so same potential difference. If battery is supplied an extra charge Q, then we can say that the initial charge on capacitor plus extra charge sent by the battery. So initial charge on the capacitor plus the extra charge sent by the battery is equal to total final charge on capacitor. And from this we can say that extra charge sent by the battery is final charge on capacitor minus initial charge. So final charge is K times to CV0, initial is CV0. Hence from this I can say that the extra charge sent by the battery is K CV0 minus CV0, that is K minus 1 multiplied by CV0. And here given in this case, K is equals to 2 minus 1, and C given as 40 microfarad. So 40 into 10 power minus 6. The potential difference is 100 volts. So this is 4000 into 10 power minus 6 coulombs. That is 4 into 10 power minus 3 coulombs. That is 4 millicoulombs is the charge on capacitor. And next, what about the energy stored in capacitor? Here initially the energy stored in capacitor is half capacitance C, same potential difference V0 square. In the second case, capacitor connected to same potential difference V0, but because of introduction of dielectric, capacitance increased by Kc. So the final energy stored in capacitor is half kc v naught square. In the question he asked change in electrostatic energy. So the change in electrostatic energy, you can write it as U2 minus U1, and from these two we can write it as half CV naught square multiplied by K minus 1. Just by substituting the values we'll get here, after calculation I got it is nearly 0.2 joules. So you can go for the simplification. This is about the first question. Now let me go through the next one. In the second question, he is asked it as find the dimensional formula of B by mu naught. So we have to calculate the dimensional formula of B divided by mu naught. B is the magnetic field induction strength, mu naught is the magnetic permeability of vacuum. Here we can use a simple solution for this. In general, if an electric current I is passing through a circular wire of radius r, then the magnetic field at the center of the wire we can write it as mu naught I divided by 2r. And from this expression, simply B by mu naught dimension will be same as I upon 2r dimension, because 2 is a number, is dimensionless. So B by mu naught dimension same as electric current divided by radius. Electric current is in amperes, radius is measured in meter. We indicate dimension of length as L. So its dimension formula is L minus 1. A simple question it is. Now let me go for the next question. In the next question, he said that an electron in the ground state of hydrogen atom has the orbit radius of 5.3 into 10 power minus 11 meter. So electron is revolving in the hydrogen atom, it is in ground state, and in the ground state the radius of the orbit is given as 5.3 multiplied by 10 power minus 11 meter. Whereas the electron, when it is in the third excited state, in the third excited state means it is the fourth orbit. So in the fourth orbit he given the radius of the electron, it is 8.48 into 10 power minus 11 meter. And from these we can say that here if you compare these two relations, that is R4 radius of the electron in fourth orbit to radius of electron in first orbit, from the given data 10 power minus 11 meter will cancel, it is 8.48 divided by 5.3. I think in the question it is given as 10 power minus 10. So you can write it as nearly 10 power minus 10 meter is given. So from these we can say that 10 power minus 10, I mean I can write it as 10 into 10 power minus 11, that is 8.48 into 10. So we can write it as 84.8 divided by 5.3. Nearly 5 16s are 80. So it is approximately equal to 16. 16 means 4 square. That is r power 4 by r power 1, we can write it as 4 upon 1 whole square. So from this we can say that 4 is fourth orbit. So from this information, if you check it, radius of fourth orbit to radius of first orbit is 4 divided by 1 whole square. This information is indicating that the radius of nth orbit is proportional to r is equal to a constant into orbit quantum number multiplied by square. So one information is given in the question only, no need to by add the relation between radius and principal quantum number, and r is proportional to n square is given. In the question he is asking that what is the ratio of de Broglie wavelength of electron when it is in excited state to when it is in ground state. So let me go for what about the de Broglie wavelength of electron. When electron is revolving around the nucleus, suppose it is going with a velocity v, its mass is m, and if the radius of nth orbit is r, the angular momentum of the electron is r bar cross mv bar. Both r and mv are perpendicular, so r mv sin 90. From Niels Bohr atomic model, it is nh by 2 pi. Here mv is momentum of electron, and from de Broglie's dual nature theory, if a particle moves with a momentum mv, then that de Broglie wavelength associated with is h by m. So from this I can replace this mv with h by lambda. So radius of orbital of the electron multiplied by momentum is h by lambda, and this is equals to nh by 2 pi. Here you see radius is proportional to n square. From this given data, I can write radius as some constant into n square multiplied by h by lambda. This is equal to nh by 2 pi. 1 n we can cancel, except lambda and n remaining all are constants here. K is a constant, h is Planck's constant, 2 pi is constant. So from this we can say that some constant k dash multiplied by n is equal to lambda. That is de Broglie wavelength directly proportional to n. So from this information we can say that the ratio of de Broglie wavelength in excited state, third excited state is 4th, ground state is 1. Because it is proportional to n, this is equal to principal quantum number of 4th orbit to 1st orbit. So lambda in excited state to lambda in ground state ratio is equals to 4. This will be the simple answer. Here is given the data of radii of the orbits, because for us no need to by heart the relation between radius and n. Total information is given in the question only. So it's a very simple question. Let me go for the next one. In the next question, he given is a uniform circular disc. A uniform circular disc is there, and radius of the disc is r, and it is having mass small m. It is rotating about an axis perpendicular to its plane, passing through its center. Means if this is the circular disc, it is rotating about an axis passing through its plane perpendicular to its center. If this is the axis of rotation of the disc, then its moment of inertia, we know that it is mr square upon 2. And next, a small circular part of radius r by 2 is removed from original disc. So from the original disc, a small circular part of radius r by 2 is removed, and this diagram is given in the question in the exam like this. So radius of this removed portion is r by 2, then remaining disc is the portion which I am combining with the lines, and removed from the original disc as in figure. Diagram is given in the question. The question is find the moment of inertia of remaining part of the disc about the axis given above, means about the same axis which is given in the earlier, that is passing through center of original disc only. He is asking moment of inertia of the remaining disc. Here from the disc this portion is removed. So this portion is removed means moment of inertia of this portion I have to subtract. When particles are added, we should add moment of inertias like m1r1 square plus m2r2 square and so on. Similarly, when particles are removed, we should remove the moment of inertias like I1 minus I2 in the same way. So what my idea is, from the total moment of inertia of the entire circular disc, let us remove the moment of inertia of this disc. But in this, moment of inertia about axis will play vital role. So what will be the moment of inertia of the cavity portion? I imagine cavity portion moment of inertia is I2. How to calculate I2? Here the cavity center is, if I imagine C1, then about axis passing through C1, we have to calculate cavity moment of inertia. Then using parallax theorem, I will shift the moment of inertia of cavity about the original center of the disk O. So for this, what about the mass of the disk which will fill the cavity portion? We have to calculate. The entire disk has uniform thickness. When thickness is uniform, then mass will vary directly proportional to area, because mass is equal to density into thickness into area. So density uniform, thickness uniform. If density into thickness is a constant number K, then K multiplied by area will be its mass. So total mass of the disk is like K pi r square. Then mass of the cavity portion M1 will be K pi and radius is r by 2 whole square. That is K pi r square by 4. So from this information I can write K pi r square as M by 4. Then moment of inertia of the cavity about axis passing through center C1 is mass of the disk M by 4 multiplied by radius of the disk R by 2 whole square. This is MR square upon 2, so multiplied by 1 by 2. This we can write MR square upon 4 to the 8, 4 the 32. So this is the moment of inertia about C1. This MR square by 32 is about C1 only. We have to shift this towards O. So for that I use parallax theorem. And let me check that. So I about axis passing through center O is equals to I about axis passing through center of mass plus mass into perpendicular distance between the two axes, parallax theorem. Here I about C1, we know it as MR square upon 32. So this is MR square upon 32 plus mass of this cavity portion disk will be, here we have derived it as M upon 4. So let me use it as M upon 4. Distance between them is R by 2 from O to C1. So R by 2 whole square. That is M R square divided by 32 plus M R square divided by, this is 4 and 16. I can multiply this with numerator with 2, denominator with 2. Now denominators are equals 32. So this is 3 MR square upon 32. This will be the moment of inertia of cavity. Now total moment of inertia will be moment of inertia of the total disk plus here moment of inertia of the cavity. The whatever the disk in the cavity, that is removed. That is why I should go for subtraction. About the cavity moment of inertia is IO. Total disk moment of inertia we know MR square by 2. From this cavity portion moment of inertia I have to remove because that mass is removed. So 3 MR square upon 32. Here we can take 32 as LCM and 2 16s are, so 16 MR square minus 3, that is 13 MR square upon 32 will be the moment of inertia of the remaining portion. Of course, simplification will need some more number of steps, but it is not a tough problem. You can simply do this. And let us go to next one. In the next question, in this question, he given it as a solid sphere. Mass of the sphere is M. Radius of the sphere is capital R. And this sphere is exerting a force F on a point mass kept at some distance outside from the center of the sphere. So imagine this is a solid sphere of mass M, and if this is the radius of the sphere, then from the sphere somewhere a point mass is placed. Distance between sphere and point mass is not given. Let it is some M, some R. Now this total solid sphere will apply a force F on small m. Small m is the point mass and this is the sphere. So force applied by total sphere on small m is F. means from gravitation concept. The gravitational field intensity due to solid sphere at a point outside is small g is equal to capital G total mass of the solid sphere by distance square. Then force will be mass of the point mass multiplied by gravitational field intensity. So I can write force as G capital M small m divided by r square. This is the first condition. Now what is given is a concentric spherical mass m by 7 is removed from it. So from the original sphere of mass m, concentrically means same center. So like this, a spherical portion of mass m by 7 is removed. From total mass m, when m by 7 is removed, then remaining portion will be 6m by 7. 7m minus m, 6m by 7. Here remaining mass is only here because concentric portion is removed. So this is the thing. Then what is the new force acting on the point mass which is kept at the same distance from the center of original sphere? Now here the total because of the sphere, the gravitational field intensity in the new case will be G. Gravitational field intensity outside a solid sphere or outside a spherical shell, both are expressions having same, that is G multiplied by total mass. Here mass of this shell after removing the spherical portion is 6m by 7, so Gm upon r square. Then what will be the gravitational force in second case? That is G dash multiplied by point mass. So 6G capital M by 7r square is gravitational field intensity multiplied by point mass. And comparing with initial, if I go, initially the force is gmm by r square. In the second case it is 6 gmm by 7r square. So in second case the force is 6 by 7 times to initial force. So that is a question he asked. In the new case the force is, the options are f by 7, 6f by 7. So 6f by 7 is given. It's a very simple and easy question. Let me go to the next question. This is a complete theoretically based reasoned assertion type. It is from the experimental physics. In a vernier calipers, one vernier scale division is smaller than one main scale division. Here the statement is in a vernier calipers. In a vernier calipers means this is the vernier calipers which we are using in the laboratory. In the laboratory, the vernier calipers which we are using, when you close the two jaws of the vernier calipers, then 10 vernier scale divisions will coincide with 9 main scale divisions. Means vernier scale divisions are less in dimension than main scale division. From this we get the idea. So here the question is vernier scale division is smaller than main scale division. So the vernier calipers which we are using in the physics lab nowadays, here for that vernier calipers, this statement 1 is correct. If the same sentence is like in every vernier calipers, maybe may not be. If anybody designed a vernier calipers with vernier scale division more than main scale, then the statement 1 is incorrect. But the statement is not like in any vernier calipers. In a vernier calipers, I mean a simple sentence whichever we use in general life. So statement 1 is correct. Statement 2, the vernier constant is given by, vernier constant I mean least count of the vernier calipers. That is given by 1 main scale division multiplied by number of vernier scale divisions. This is incorrect. Least count is related to 1 main scale division minus 1 vernier scale division. So that doesn't coincide with the second statement. So second statement is wrong and first statement is correct. Let us go to the next one. This question is from the vertical circular motion. So in this question, whatever is given is the bob of a simple pendulum of mass m is suspended at a point O. Imagine this is the vertical circular path moved by a bob, and this is the point of suspension O. Here bob's the lowest position is here. So a diagram is given. The lowest position is indicated as A, and somewhere a position is B, and another position is C, and topmost position of the bob is D, given in the diagram. And it is also given in the diagram that this is 60 degrees angle and this is 60 degrees angle, and length of this length of the string between point of suspension to bob is L. The question is, this bob perform vertical circular motion? Initially, by applying a horizontal velocity V naught at A, given in the diagram, the string becomes slack when the bob reaches at the point D. So when bob reaches point D, at this instant string becomes slack. Means up to just before D, string is tight, means some tension exists, and just at D, tension in the string becomes 0. When tension in the string becomes 0 at D, then only gravitational force is acting on the bob. If the bob velocity at D is some Vd, then from the concept of centripetal force and centripetal acceleration, net force acting on the bob is mg, and that mg is equals to mass of the bob into centripetal acceleration, that is Vd square divided by radius of circular path, that is distance from point of suspension to bob, that is L. So from this we can say that velocity at D will be root of GL. If you apply conservation of energy between the points A and D, we will get the velocity of the bob at A will be V naught is equal to root of 5GL. Here, why we have to apply conservation of energy? No friction is acting on it, and no non-conservative forces are acting on it, no loss of energy, even work done by tension 0, only mg is working, so it will keep total energy constant, hence you can apply conservation of energy. And this velocity at A will be root of 5GL. Now what is asking in this question? In this question, he is saying that find the ratio of the kinetic energies when the bob is at point B and at point C. In the vertical circular portion, here point B is making 60 degrees angle from vertical. So when it is shifted from point A to B, again if I conserve energy, at A the velocity V naught is root over 5GL. So V naught square is 5GL. Then if I take A as 0 level potential energy, so at A if I take potential energy 0, so potential energy 0, kinetic energy half m V naught square, that is V naught square is 5GL, and total energy at B will be how much? Length of the string is L, so this portion will be L cos 60, that is L by 2, and this is total length of the string L. L minus L by 2 is L by 2. So B is L by 2 height above capital A. So if at A potential energy is 0, at B potential energy will be mgL by 2, and at B kinetic energy will be half mvb square. Let us imagine he asked only kinetic energy, so I don't want to cancel masses. I will keep the kinetic energy terms as it is. This is 5 mgL by 2 minus mgL by 2 is 5 minus 1, 4 mgL by 2, that is 2 mgL is the kinetic energy of the bob when it is at point B, half mvb square. Next, let us go to other point. The other point is at C. When it is at point C, again the thread is making 60 degrees with vertical. Now let me go to that. In the vertical circular motion, Here when it is reached to point C in this portion, again this angle is 60 degrees. So length of the string is L and this side will be L cos 60, that is L by 2, and from point A, here this distance is also L because bob to point of suspension O. So total height of the position C is L plus L by 2, 3L by 2. If I imagine at C velocity is Vc, again if we go for conservation of energy, at A we treat gravitational potential energy 0, kinetic energy is half m, velocity at A is root 5gn, so Va square, and this is equal to potential energy at C is L plus L by 2, 3L by 2, so mg into 3L by 2 plus kinetic energy at C, that is half m Vc square. Now 5mgl by 2 minus 3mgl by 2 is mgl. So kinetic energy at C half m Vc square will be mgl. And the question is ratio between kinetic energy at B and at C. Here from earlier derivation, the kinetic energy at B is 2mgl and kinetic energy at C will be mgl. So kinetic energy at B divided by kinetic energy at C will be 2mgl upon mgl. So they cancel, you will get remaining is 2:1. So the answer is 2. This is the problem. And let us go to next one. The next question is related to geometrical optics. In this question, he given that there is a thin convex lens prepared with glass, refractive index mu, and each surface having radius of curvature capital R. One side is polished so that light will suffer complete reflection. At what distance from the lens an object be placed so that optic axis from the optic axis so that image sets finally on the object itself. Here when you take any lens, if you take one surface of the lens is silvered, this can behave like a concave mirror, and in case of a concave mirror, object and image will coincide only when the distance from object to center of mirror u is equal to 2 times 2 focal length of the mirror, because object distance 2f and image distance, you can use the mirror equation from 1 by v plus 1 by u equal to 1 by f. From this you will get when v and u are equal, in case of concave mirror u will be 2f. Means in this problem I have to calculate object distance, means I have to calculate focal length of this effective mirror. So let me go for the focal length. In this case, there is a convex lens and this side is silvered. So when light rays travel at instant, first they suffer refraction, so it behaves like a lens. Then light rays suffer reflection from the silvering surface, behave like a concave mirror. Then while coming out, they again suffer refraction, so behave like a lens. So it's a combination of lens, mirror and lens. That is why the equivalent focal power 1 by f equals to focal power due to lens plus focal power due to mirror plus focal power due to lens. Hence we can write this as 2 times 2 1 by fl plus 1 by focal length of mirror. Naturally, in case of mirror, the focal length is half of radius of curvature. So only I have to calculate focal length in case of the lens. Let us go for the focal length in case of lens. Using the lens maker equation, surrounding medium is air, refractive index 1 upon focal length of lens equals to mu2 minus mu1. So lens material is mu, this is 1. And for first surface, radius of curvature is positive 1 by r according to sign convention, 1 by r1 minus 1 by r2. For second surface, minus 1 by r. So this will be 2 by r. So 1 by focal length of the lens will be 2 into mu minus 1 upon r. Then 2 times 2 focal length of the lens will be 4 into mu minus 1 by r. Then equivalent focal length of the total system is 2 by focal length of lens plus 1 by focal length of mirror. That is 4 into mu minus 1 by r. That is 4 mu minus 4 by r plus focal length of mirror is r by 2. So 1 by this is 2 by r. R is LCM. And here you will get the 1 by equivalent focal length is 4 mu minus 4 plus 2, that is 4 mu minus 2 by r. You can take 2 as common, then 2 mu minus 1 by r. This is the focal equivalent focal length. When the object distance is 2 times 2 equivalent focal length, in case of mirror, image and object both will coincide. Hence, the object distance will be 2 times 2 focal length. That is 2 times 2 r upon 2 into 2 mu minus 1. So 2 balances with each other. Then the object distance will be r upon 2 mu minus 1. This will be the answer for this question. Sorry, r upon, it is u is equals to r upon 2 mu minus 1. So this is the one. Let us go to next one. In the next question, he given that an electron is made to enter symmetrically between two parallel and equally opposite charged metal plates. Let me take one charged metal plate above, another charged metal plate below. Suppose the upper metal plate is positively charged and lower metal plate is negatively charged, equally spaced, so it will enter from the midpoint. And second thing, here length of each plate is given. This is 10 centimeter in the problem. And the electron emerges out of the electric field region with a horizontal component of 10 power 6 meters per second. Imagine if some velocity is given to this electron here horizontally V0. Now here plus q and minus q, these charges will produce an electric field away from positive and towards negative. Because electron charge is negative, a negative charge experience force due to electric field opposite to electric field. That force F is equals to charge multiplied by electric field intensity. Charge of electron is small e. If this is the force of electron acting in vertical direction, then acceleration of electron in vertical direction is force acting on electron divided by mass. Here we are neglecting gravity because gravitational force is very smaller comparing with the electric field. Now if a force is acting on the electron in upward, if any horizontal velocity is given, so horizontally no force acting on it, so it travel with constant velocity v0 and gradually it will deflect in vertical direction. So finally when it is coming out from the electric field, the horizontal component remains same. In the problem, he given that horizontal component of velocity of the electron is 10 power 6 meters per second. Here in horizontal direction, no force is acting. So no acceleration for the electron in horizontal direction. When there is no acceleration, then it is traveling with constant velocity. You can use a simple concept. Displacement traveled in horizontal direction is velocity multiplied by time. From this I can go for time is equal to displacement, that is 10 centimeter, that is 10 by 100 meter, because 1 centimeter is 1 by 100 meter, upon velocity of the electron, that is 10 power 6. And 1 0 cancel. In the denominator 10 power 7 means the time is 10 power minus 7 seconds. And within 10 power minus 7 seconds, it is also producing an acceleration in y direction. The question is given is magnitude of electric field is given 9.1 volt per centimeter. The question is What is the vertical component of velocity of electron? Here the vertical component of velocity of electron when it is coming out from the plates. That is the information, that is the question he is asking. So for this problem, if I select all y components, then v is equals to u plus at from this vector equation. If I take all y components, then final velocity y component we need. Initially no velocity y component is given, and acceleration y component is force small e capital E divided by mass of electron into time. Here small e is given in the question, and that is 1.6 into 10 power minus 19 coulombs, and electric field given in the question is 9.1 volt per centimeter. Here if you go for the units, 9.1 volt upon centimeter, I can write it as 9.1 volt upon centimeter is 1 by 100 meter. So 100 goes to numerator, that is 9.1 into 100 volt per meter. If you convert in SI system, so 9.1 into 100 volt per meter is electric field, multiplied by time is 10 power minus 7 seconds, divided by mass of electron given in the question is 9.1 into 10 power minus 31 kg. 9.1 naturally cancels. Then if you go for all these, 1.6 will remain, and 31 here plus 1, 32, 31 plus 2 is 33, minus all these, if you go for calculation, it is approximately 16 into 10 power 6. So 1.6 into 10 power 7 actually I think I will get, and option given is 16 into 10 power 6 coincides with this in meters per second. Go for the calculations. I am leaving the simplification to you. Let me go for next question. This is from waves in air, that is stationary waves in closed and open argon pipes. Here the closed argon pipe and an open argon pipe are completely filled by two different gases having same bulk modulus but different densities ρ1 and ρ2. In the case of a closed argon pipe or an open argon pipe, we are getting stationary waves in the air column, and the velocity of longitudinal waves in an air column is under root of gamma p by rho, where gamma p is the bulk modulus of elasticity according to Newton-Laplace equation. So I can write here velocity is equals to under root of bulk modulus upon density of the medium. So here the ρ1, ρ2s are densities given. So here density of air is ρ1, here densities of air is ρ2. Then velocity of sound wave in first pipe is v1 and in second pipe is v2. The first pipe is a closed argon pipe and second pipe is open argon pipe. Here the question given is frequency of ninth harmonic of closed tube is identical with fourth harmonic of open tube. Let me go for this. From V is equal to n lambda, or you can go simple condition. Here frequency of ninth harmonic of closed pipe. In the case of closed pipe, fundamental frequency is V by 4L, as we know. Ninth harmonic means 9 times to V by 4L. So 9 times to V in the closed pipe upon 4L, that is length of closed pipe, is same as the frequency of fourth harmonic of open pipe. So fourth harmonic in open pipe fundamental is V by 2L. It is open pipe VO and LO, and fourth harmonic means multiplied by 4. So from these we can go for 2 2s of 4, and here velocity of sound wave in closed pipe upon velocity of sound wave in open pipe is equals to here 4 2s are 8 times 2 length of closed pipe divided by 9 times 2 length of open pipe. And what about the velocity ratios in closed and open? The velocity of sound in closed divided by velocity of sound in open are under root of bulk modulus divided by density of air in open and bulk modulus divided by density of closed. So velocity of sound waves in the two pipes are in the ratio under root of rho 2 upon rho 1. And the ratio of the densities rho 1 and rho 2 given in the question are 1:16. Rho 1, rho 2 are 1:16. So rho 2 and rho 1 are 16 upon 1. Root of 16 upon 1 is 4. So this ratio is 4. Now that is 4 equals to 8 by 9 times 2 closed pipe length and open pipe length. So 4 is equals to 8 by 9 times 2 closed pipe length and open pipe length. So closed pipe length and open pipe length. Here 4 times 2. So length of closed pipe is equals to 9 times 2 length of open pipe upon 2. The question is length of closed pipe given as 10 centimeter. What is the length of open pipe? That is 9 LO upon 2. So length of open pipe will be 20 by 9 centimeter. So this is the answer. It is also a very, and one more problem is from the gravitation only. In this case, given that a small point mass m is placed at a distance 2r. So this is a big uniform solid sphere of mass m and radius r given, and from the big uniform solid sphere a point mass is placed at a distance 2r. Here is a point mass placed at a distance 2r. It is given in diagram also in the question. And here gravitational force on small m due to this total sphere is F1 given. So F1 is equals to G, and because of sphere gravitational field intensity is Gm by distance from center to center of the sphere to there, that is 2r whole square, 4r square. Gravitational field intensity into mass is gravitational force. So gravitational force we can write it as Gm square by 4r square. This F1 is given in the question. And second is a spherical part of radius r by 3 is removed from the big sphere. So let me check. From the big sphere, a spherical part of radius r by 3 is removed, and the removed portion is given as it is like this. Diagram is mentioned. So this distance is r by 3. Then if this is removed, then the remaining portion gravitational field intensity will be from the total gravitational field intensity due to this we have to remove. So from the total let us first find what will be the gravitational field intensity due to removed part of the sphere. See, from the original sphere to the point mass m, the distance is 2r. So this is r by 3, then this distance will be total r minus r by 3, that is 2r by 3. Then distance from center of this portion to the point mass is 2r minus 2r by 3. From total 2r, remove 2r by 3, you will get, that is 6r minus 2r, 4r by 3 we are getting. Then due to this removed portion, what will be the gravitational field intensity? That is G dash is equals to, here removed portion mass we should know. Here mass is equal to density multiplied by volume. Volume of the sphere is proportional to radius cube. Then removed portion mass will be same density, and radius is r by 2 whole cube, r by 3 whole cube. That is, this is equal to from total mass of the original sphere by 3 cube, that is 27. So mass of this removed portion will be m upon 27, and distance from center of the sphere to there is 4r by 3. So gm by r square means gm upon 4r by 3 whole square. And this we will get the gravitational field intensity as, here 3 square is 9, 9 3s are 27. So 3 will be there, and 4 square, that is 16 3s are 48. So GM by 48 R square. This will be the gravitational field intensity of the portion which will be removed. Then what will be the remaining portion gravitational field intensity? That remaining portion gravitational field intensity will be from the total, remove this portion, and that is Nana from the total is Gm by 2r whole square, that is 4r square, minus due to the removed portion it is Gm by 48r square. So Gm upon 48r square. Here 12 fours are 48, so I multiply numerator and denominator with 12, and 12 minus 1 is 11 Gm divided by 48 R square. This is the remaining portion. Then the gravitational force due to remaining portion F dash will be gravitational field intensity multiplied by point mass, that is 11 Gm multiplied by m square upon 48 R square. Here the question whatever he asked is find the ratio of the two forces. The first force, if it is in the first case the force is Gm square by 4r square, and he is asking ratio between these two, that is F upon F dash. So F upon F dash, if you see here Gm square by R square we can balance, and remaining is in the numerator it is 1 by 4 and in the denominator it is 11 upon 48. So the answer will be 1 by 4 multiplied by 48 upon 11, that is 12 is to 1 we are 11 we are getting. So the option is he is asked in reverse. 11, okay, 12 is to 11 is given. So that's about the paper according to the memory of the students. All the best.